Okay, so we are back solving systems of equations. And then we are going to continue with part 2, which was elimination. So just like before, you want to, each time you get a system of equations, in order to solve it, you want to go through the types one by one in order to make sure that you're solving the system in the easiest way possible. So once again, if you have two equations that start with y equals, then that's a type 1, and you set them equal to each other and solve. If you don't have any equations that start with y equals, then you're looking for, do you have opposites? Do you have a zero pair in there? And you can cancel them out and add, just like we did in type 3. Or if you have either the x's or the y's are exactly the same, then you can multiply one equation by -1, and that would be the easiest way to solve that. So if none of those will work, then you can try type 5, which is you can multiply one equation by any number to create a zero pair. So we're going to start off with a relatively easy example. Example 1 is x plus 3y equals 1, and -2x plus 5y equals -13. So clearly we can see that we don't have equations that start with x equals or y equals something. We don't have a zero pair in the x's. We don't have a zero pair in the y's. Obviously, neither the x's nor the y's are exactly the same. So now we look to see what could we multiply one equation by in order to still create the zero pair, because this is still elimination, so we're still trying to get rid of either the x's or the y's. And the way that we do that is we create a zero pair. So in this case, when you don't have a number in front of the variable, like in front of this x, then you think, well, what number would I need to be in front of this x so that it would cancel out with the other x? So since the other x is a -2, then the opposite or the zero pair to that would be a +2. So we can't just sneak a 2 in front of that x and call it a day. We have to multiply that whole first equation by 2 in order to keep this equivalent. So now instead of just x, now that becomes a 2x, and then 2 times 3y is 6y, and then 2 times 1 is 2. So that all I did was I multiplied each of these by 2. And then we want the second equation to stay the same. So -2x plus 5y equals negative 13. So now I can see that I have a zero pair, I have a positive 2x and a negative 2x. So that what we've done is we've created a type 3 system. We have a zero pair, so we can cancel those out and add what's left. So we have 6y plus 5y is 11y, and 2 minus 13, which is negative 11. And then all I need is one wall floor divided by 11, and then negative 11 divided by 11 is negative 1. And then, of course, at this point, we all know that we're not done yet. We have to take that value of y and plug it into one of those equations so that we can solve for x. So if I take the original first equation, I could choose any equation. I could choose an original equation. I could choose an equation that I changed. It doesn't matter. But that first equation to me looks like it would be easier. So it was x plus 3y. So now it's going to be x plus 3 times negative 1 equals 1. And then from here, I have x plus 3 times negative 1 is negative 3. So I could have just written that as x minus 3. Either way, then all I need to do is a wall floor. The opposite of that negative 3 is a positive 3. So that those cancel. And then 1 plus 3 is 4. So that now the answer to this is 4, negative 1, because as always, we're writing the answer as x comma y. Okay, so that's the beginning of type 5. We'll move on to example 2 in the next clip.